Hi everyone, this is Shubho with Shiv's Solution. This is the video made the troubleshooter of your maths phobia. If you feel it's worth of watching, please take a second to hit like and subscribe to our channel. Well dear students, before we go to this video, please make sure that you have watched previous videos which is linked to these videos. Okay, well now this video will start with the unit vector. Unit vector in a particular given direction. So dear students, let me take here one example. Please have a look at the diagram. Here is the vector A. Here is the vector A. It goes in particular direction. It goes in this direction. If it is going in this direction. See here the vector A is it some magnitude. Maybe 10. Imagine it's a 10 or it's maybe 20. I'm going to take it as a 5 meter or particular, whatever it is, kilometer, your wish it is. Okay. So there is one vector. They have given a vector with some magnitude in particular direction. Now I want a unit vector. Now I want a unit vector in the same direction. I want a unit vector in the same direction. So how to get the unit vector in the same direction? Very simple, dear students. So whatever the vector they have given, just to find out its magnitude, just find out its magnitude, the given vector magnitude you find out, and then divide that vector by its magnitude. You will be getting the vector of length 1. Vector of length 1. So whenever a vector with a length 1 or magnitude 1, we call it as a unit vector. I mean, just imagine, see, if it is a 8, if you divide it by 8 means you will be getting 1 only. Yes, I want to get to 1. Length is 1. So to get that length is 1, just divide it by the length what you have with that same length. Then you'll be getting the length 1. Okay. So this is the way we are going to find out the unit vector. And after finding the unit vector, the unit vector of vector A in the same direction will be denoted by A cap. This is the things which you are going to study in the unit vector. Please keep in mind, unit vector is a vector of magnitude 1. This already you know, which we are discussing in the first video, correct? So unit vector of a vector A will be denoted by A cap, and that will be represented. This is the way. What is that? So given vector divided by its magnitude. Okay, dear students, let's study the components of a vector. Components of a vector. So there are some components of the for the given vectors. So now we have studied the vectors. Okay, so now let's study its components. So what are the components? Please have a look at this diagram. I have taken 3 points, A, B, and C. A, B, and C. I have taken 3 points, A, B, and C. Okay, so a point A lies on the x-axis. Point A lies on the x-axis. So automatically we will come to know that if it lies on the x-axis means the y and z coordinate will be 0. Similarly, point B lies on the y-axis. So x and z coordinate will be 0. And point C lies on the z-axis. So x and y coordinate will be 0. X and y coordinate will be 0. Correct? So now let me take these 3 points which lies on the x, y and z axis respectively. Then what is the length of that each point? What is the length of each point? See, OA, OB, OC. If you find the magnitude, that all magnitudes will be with magnitude 1. That all vectors, I mean vector OA, vector OB, and vector OC. So all these 3 vectors will be with the magnitude exactly equal to 1. So that is the reason I call vector OA and vector OB and vector OC are unit vector. I call these vector OA and vector OB and vector OC are unit vectors along with, please keep in mind, dear students, these all are vector along with the particular axis. I mean OA is on along x-axis, OB is on y-axis, OZ is on, OC is on z-axis, OC is on z-axis. Okay, these all are called the unit vectors, and these unit vectors will be denoted by, please, very important, this you have to keep in your notes, these unit vectors, so which lies along the, I mean the impact of a particular coordinate on x-axis will be represented by I, y will be j, and z axis will be, we take it as a k. Okay, these all will be unit vector representation of x, y, and z axis. So unit vector on the x, y, and z axis will be represented by, please, I cap, see, I cap, j cap, and k cap. This is the way we are going to represent the unit vectors. And vector y is equal to here. So vector y is equal to x into I, xi cap. Vector OB. So whatever may be the coordinates we take. If you take the any other coordinates, x value as something, y value as something, z value as something, this is the way we are going to represent the particular vectors now onwards. Okay. So y is equal to here xi, OB is equal to yj, and OC is equal to zk. Well, dear students, let's move to the next, that is position vector. Yes, already we have studied position vector in the first video, correct? But here we have to study the position vector in particular form. What is the component form? Here we are going to study the component form. What are the components are there in this position vector? So please let us have a look at this diagram. Please have a clear, want to get a clear picture, please just make note this diagram. I have taken a point P. I hope you can see here. I have taken a point P with coordinates x, y, and z. I have taken a point P with coordinates x, y, and z in space. I have taken it in the space. Okay. And then what will be the position vector of OP? Already you know. Sorry. The position vector of P is OP. Correct? The position vector of P. The position vector of this point P is OP. So the position vector of point P is OP. I'm going to take it as a vector R. Or you can take it as a vector OP or vector R. Correct? Vector OP or vector R. Okay. So now I want to find out, just please before that, once again let me come back. P is a point in a space with coordinates x comma y comma z, and OB the origin 0 comma 0 comma 0. Okay. Then the position vector of P is OP. Then the position vector of P is OP. So here we know that. What's that? I, J, and K are the unit vectors. We know that I, J, and K are the unit vectors. Correct? Any doubt in this? Just previous slide we have studied. Okay. So here I, J, K are unit vectors. Now just please have a clear picture. Here OQ. OQ will be Xi. Then what will be QP1? The QP1 will be YZ. Correct? Because this is parallel to this one. Correct? Equal to this one. So here QP1 is equal to Y1. QP1 is equal to Y1 and OQ is equal to XI. OP is equal to XI. This is XI and QP1 is equal to YJ. Now I want OP1. So then what will the OP1? Please apply the triangle of addition. So that is OP1 is equal to OP1 is equal to what I get here? XI plus YJ. XI plus YJ. Okay. Then now let's come back to the OP. I want now OP. So I want OP, not OP1. Now I want OP, vector OP. Now I want vector OP. So then what will the vector OP? See, vector OP is equal to OP1 plus PP1. Correct? Vector OP1 plus vector PP1. Correct? Do you agree with me? Yes. So here I want vector OP. As already said, position vector. I want to study the components of the position vector. What are the components are in the position vector? Okay. So before you get position, first let us find the position vector. That is OP. Let us find it. So OP is equal to, I got OP1 plus PP1. Now what is OP1? What is OP1? Which already you have studied here. It is XI plus YJ. XI plus YJ plus. What is PP1? So PP1 is nothing but, see, this is PP1, which is nothing but equal to Q. You can take Q this one, or you can take OR. Okay. So OR is nothing but ZK cap. And finally I got OP is equal to vector OP is equal to OP1 plus PP1 is equal to XI plus YJ plus ZK. So finally, please, dear students, keep in your note. Then the position vector of OP. Then the position vector of OP with the coordinates x, y, z is equal to, with coordinates x, y, z is equal to xi plus yj plus zk, which you can also take it as a vector R. So this we call it as a component form. This kind of vector. This form of vector, we call it as a component form. And here very, very important things what I'm getting now. That is here. Can you see x, y, and z? So these x, y, and z are called the scalar components. Are called the scalar components. You can call it as a direction ratios as well as scalar components. Very important, dear students. These we call it as, they can ask this for the one mass. This we call it as x, y, and z. I mean the coefficients of I, j, and k. We call it as a scalar components, and there is one more component which may also ask for one mass, that is xi comma yj comma zk. Sorry dear students, it is comma xi comma yj comma zk are called the vector components of the vector. Xi comma yj comma zk are also called the vector components of vector R. So only x, y, and z are called scalar components, and xi, yj, and zk are called the vector components of vector R along the three respective axes. Then what is the magnitude of vector R? I want to find the magnitude of vector R. I mean distance, length. So that is already what you know. Root of x square plus y square plus z square. X square plus y square, z square. Okay, yes, let's go to the further. That's components of a vector. I mean, when you do the addition of a vector to vector and some other things, what will be the components of that vectors? So let us do the first vector operation. In that vector operation, let there be two vectors. Then there will be two vectors, which are the vector A and vector B. So vector A has A1 impact on x-axis, A2 on y-axis, A3 on z-axis. Vector B has B1 impact, B2 and B3 impacts on the x, y, and z-axis respectively. Okay, now if you do that, now I want to add these both the vectors. So when you add these both the vectors, then how to add these vectors? The first thing is how to add these vectors. So simple, dear students. Just when you want to add the two vectors, just add the corresponding elements A to B. Means I coefficients of I of vector A and coefficient I of vector B. So A1 plus B1, A2 plus B2, A3 plus B3. This we call it as a addition of two vectors. So just adding the corresponding elements. Similarly, next one is difference of two vectors. So same thing, just you can find out the difference of two vectors by taking the subtraction of corresponding elements of the given two vectors. Similarly, the next one is if you want to say that given two vectors are equal. Here vector A and vector B are, if you want to say that equal or if it is equal, then there is one condition. What is that? Compulsory here the corresponding elements. I mean A1 should be equal to B1, A2 should be equal to B2, A3 should be equal to B3. So this is the condition for to say that any two vectors are equal to each other. The next one is multiplication of a vector by scalar. Already we have studied, dear students, that if you multiply any vector, with a one constant, I mean with a scalar, then that will be, I mean, just imagine here I'll take vector A is equal to 3i plus 4j plus 5k. Then I want to multiply with a scalar number 3a. Then what you get, it is 3 into 3 is 9, 3 into 4 is 12, 3 into 5 is 15. So this is the way of multiplication of a given vector by one constant number. I have multiplied here by one constant lambda. Okay. So next, the concept is distributive law. Which already you know studied in the many chapters. So what is the distributive law? Simple. Let us take the two vectors along with two scalars. I'm taking two scalars here. That k and m with it, any two scalars means any two numbers. We already have one number here, one value. Okay. And vector A and vector B are the any two. I have taken two vectors. Okay. If I do the sum of two vectors which is already multiplied by the two different scalars, which also can write it as equal to the sum of that two scalars. Into vector A. Sorry, not two different vectors I'm adding here. If you multiply a given vector by two different scalars, and if you add that both, that will be equal to the sum of that two scalars into that given vector. Now the second property is if you multiply the scalars by changing its order with that vectors, will not get the change. I mean k into m into vector A will be equal to k into m into vector A. Similarly, so if you add multiplication of a scalar of any one scalar with the sum of the two vectors will be equal to the sum of the product of that vectors with the any one of the given scalar. So these two will be equal to each other. So now let's move to the next one, that is collinear vectors. Dear students, already in the first video itself we have studied in the types of vectors only we have studied collinear vectors. What is collinear vectors? You know already collinear vectors. What is collinear vectors? The vectors which said to be collinear if when they are with the same when they are parallel irrespective of their magnitude and direction. They should be parallel to each other. Okay, as already I said you in the multiplication of a vector, I think, okay, when you multiply any given vector with a one constant number, so that vector will be goes in the same direction, in particular direction, except based on the number based ones, if it is a plus or if it is a negative. So just multiply a given vector with any one of the constant number, the particular vector will be goes in the same direction or in the opposite direction. Same direction or in the opposite direction. But that will be always parallel to each other. That we can call it as a collinear vectors. I mean, like they will be giving you one vector A. Okay, they give you vector A, that is I plus J plus K. And they will be asking you find out the collinear vector with this vector A. So there are many vectors. There are infinite vectors which is collinear to vector A. How to get that? Very simple, dear students. Just multiply by whichever number you want. You can multiply with 3 into vector A, 4 into vector A, or 5 minus 5 into A, whatever number if you multiply. So that two vectors may goes opposite direction, but that will be definitely parallel to each other. That vectors we call it as a collinear vector. Okay, so here given it is two vectors. Vector B is this one, vector A is this one. If vector B can be written as if vector B can be written as a lambda into means some scalar into vector A, then you can say that the two given vectors, vector A and vector B, are collinear to each other. So here very important concept, that is, so when you want to say any two given vectors are collinear, when you want to say that when two given vectors are collinear, just keep in your mind that corresponding or that will be proportional to each other. Vector B and vector A will be proportion to each other. They will be in proportion to each other. So here the note. Yes. See here vector A, as always said you, that coefficients of I and J and K can be called it as a scalar components, as well as you can call it as the direction ratios of the given vector A. Given vector, direction ratios of given vector. And similarly, we know that in the first video study, L, M and N are known as what? Direction cosines. Okay, so Li plus Mj plus Nk, I mean cos alpha I plus cos beta j plus cos gamma k is a unit vector always. So whenever I, j, k, if you write it as Li plus Mj plus Nk, that will be always unit vector. So what I'm trying to say here means the coefficients of unit vector, you can call it as the coefficients of unit vectors, you can call it as always direction cosines. The coefficients of unit vector. The coefficients of unit vector will be always, you can call it as a direction cosine. They will ask you to find out the direction cosines. Very simple. Find out unit vector. First, how to find out unit vector already have discussed. Find out unit vector and just write on the coefficients of that unit vector, of the coefficients of that I, j and k. That is the direction cosines of the given vector. Okay.